Hi and welcome to this video on logarithms. Now logarithms are the inverse of exponential functions. If we have a look at the definition of a logarithm, the log of a number is the exponent the base must be raised to give that number. Sounds a little confusing, but let's start and trying to explain it. So if we have 10 times 10 times 10, that's 3 lots of 10, that's 1,000. We write that as, in exponential form, 10 to the power 3. In the logarithmic form, we say the log base 10, so this is the base, log base 10 of 1,000 equals 3. Let's have a look at another example. So if we had 2 times 2 times 2, that equals 8. So the log 2 of 8 is equal to 3, because there are 3 lots of 2 there. 1, 2, 3. So the log of a number is the exponent, so that's 3. The base must be raised to, which is, the base is 2, to give that number. So 2 to the power 3 equals 8. 2 to the power 3 equals 8. Let's have a look here now. So in this question, 3 to what power, we can look at it like that. 3 to what power is 9. So 3 to what power or exponent is 9. And what we do here is, I'd like to look at it like a little scorpion's tail. So it goes round, and then the scorpion's tail goes like that. So we have our little scorpion with its claws, and 4 pairs of legs. So follow it round, so we go 3, let's pull this up a little bit, 3, follow it round, to what power is 9. And when we do that, we say 3 to the x to what power equals 9. 3 to the power 2 equals 9. Therefore x equals 2. Okay, here we have a comparison of the laws of exponents and the laws of logarithms. The laws of logarithms. The log of 1 is 0. Also, the natural log of 1 is 0. When we're adding logs together, it becomes a division and vice versa. This equal sign in each case can be considered as a reverse sign as well. So if you have the log of x and the log of y to the same base plus each other, they can be rewritten as log of that base, the same base, x multiplied by y. The log of 1 over x becomes minus log of x. the log of a quotient, we subtract the log of a quotient, we subtract the top, which is x, minus the bottom, which is y. Here we have the log of a power. We can bring the power down. So usually I do that like an arrow. We bring the arrow down, and this becomes y log of x. This is the change of base formula. So if we have a log in a base and we want to change that base, we take this big number here, or the big x, and put it over the log of x over the log of the smaller, the base, which is log of a, and have the same base on the top and the bottom. The log of a to the a equals 1, and also similarly the natural log of e equals 1. Wherever we see the base and the same number next to each other, that becomes 1. Let's have a quick chat about natural logs. Natural logs we write as ln, and a log, when it's written that way, which is a standard log, we take as log to the base 10. A natural log is log to the base e is natural log, where e is Euler's constant. The natural log of 1 is 0. And this equals e to the 1. So let's have a look at this. So if we have the natural log of e, this equals log e, like we said there, and this equals 1. So log e to the e, because this e and this e cancel each other out, or we consider them to cancel each other out, becomes 1. This is very important when we're working with natural logs and we do something called exponentiation of the equation. The natural log of 1 over e squared is log e to the minus 2, which is minus 2. And let's have a look at the natural log of the square root of e is log e to the half, which equals a half. In all these cases, log to the base e can be written as natural log. Now let's use this property of logs to solve some logarithmic equations. In this first one we can't use the rules of indices because the bases are different. So we're going to have to use a log law, and the one we're going to use is log a of m equals m log a. So first of all we bring down this as we can using the log laws. So 2x minus 1 log 2 equals, bring down the x log 5. Get rid of the brackets, we get 2x log 2, and then the minus 1, we get minus log 2 equals x log 5. We collect the common terms, so we get 2x log 2 minus x log 5. So we're bringing all the x terms onto one side, and that equals, bring the log 2 onto the other side, that becomes log 2. We factor out x, we get x 2 log 2 minus log 5 equals log 2. And now to get x by itself, we just bring this to the bottom, divide by that, so we get log 2 on the top, and on the bottom we have 2 log 2 minus log 5. In this second question, or the second equation that we have to solve, we use the property where 2 to the x equals quarter our scorpion's tail. So we have 2 to the power x equals 1/4. So 2x equals, we're going to make the bases the same, 2 to the power 2 all over 1. 2x, we'll get rid of the brackets. I'll bring the 2 to the top really first. Let's get rid of the reciprocal. It's 2 to the 2 to the minus 1. Now let's get rid of the brackets. So 2x equals 2 to the minus 2. So x equals, because the base is now the same, x is minus 2. Okay, in this first question, we have a half to the power of x equals 1/16. So we've changed this log into an exponential. Now we can use our exponential laws, or laws of indices. So half is nothing but 2 to the minus 1. X. 16, the reciprocal is 16 to the minus 1. Now what we want to do is try and make the bases the same, so this becomes 2 to the minus x. 16 is 2 to the power 4. So 2 to the minus x is 2 to the minus 4. Because the bases are the same, we can ignore those. And the powers are equivalent to each other, so minus x equals minus 4. So x therefore equals 4. This next question, we talked about log. When it's log by itself, we take it to be base 10. So this is log base 10. Square root of 10 equals x. Do our scorpion. So 10 to the power of x equals Now the square root of 10 is 10, when we remember our laws of indices, 10 to the half. Here we have the bases the same, so x equals a half. So we use our little scorpion, 10 to the x equals we take this as an exponential, so 10 to the x is 10 to the 1 over 4. Now our bases are the same, so x equals 1/4. The same here, let's go 4 to the x equals 2, 5, 6. That should be 3 in the original question. So 4x equals 4, 2, 5, 6 is 4 to the power 4, and this is 1/3. So 4x equals 4 to the 4/3. We've got the bases the same, so x equals 4/3. In this last question now, square root of 5 to the x equals 25. So square root of 5 is 5 to the half, power half, x, and 25 is 5 squared. So this becomes 5 x over 2 equals 5 over 2. We've got the bases the same, so x is 5 over x over 2, so we can ignore the 5's, so that just becomes 2, and then x equals 4. Okay, a slightly different type of question, in a little bit of algebra. We're asked to express p in terms of q. Now the first thing we see is the bases of the logs are different, so we want the bases to be the same so that we can continue with our log laws. So our change of base formula, we take the log for q, we put log q, the big one, on top, and the log of the base, the little base, on the bottom, and then we just choose a base, and the base we want is 2 because we're using that one, 2. So this now becomes this using our change of base formula. So this then becomes log 2p minus log 2q divided by log 2 or equals 2. Now the log base 2 of 4 is 2, so we can see how we got to that. So 2 to 2 equals 4. So this bottom can be replaced by 2, so this becomes log 2p minus, now if we have 2 on the bottom, that becomes a half, log 2q base 2q equals 2. Now what we need to do is, we've got a half here, we can use our log a to the m equals m log a. Now what, use the reverse of that, so we bring this half up here, so this becomes log 2p minus log 2q to the half equals 2. Now we can combine our logs using our log laws, so this becomes log 2, so this one becomes the numerator, p, and this becomes the denominator, q to the half equals 2. Now what we can do is, again, apply our scorpion rule, which goes up there. So 2 to the power 2 equals p q to the half. So that's 4 equals p q to the half. And then our final answer, p equals 4 q to the half. First of all, let's combine our logs. So we take this to this side and bring the minus 1 to the other side. So this becomes log x plus log x minus 9 equals 1. Now, because of this addition sign, we use the property of logs. We multiply together, so log x times x, or multiplied by x plus 9 equals 1. Now this log is log 10, so if we take this using our log law, this becomes 10 to the power 1 equals x squared plus minus, sorry, that should be a minus, x squared minus 9x. So x squared minus 9x equals 10. X squared minus 9x minus 10 equals 0. This is a quadratic which we factorize and we get x minus 10 x plus 1. So the log of minus 1, so this x could be minus 1 and x equals plus 10. Log of minus 1 is undefined, so our answer is x equals 10. Okay, let's go over some uses of logs. If we go through some log laws, so we get if a is 10 to the power n and b is 10 to the m, log a is n and log of b equals m. So AB, using our log laws, is 10 m plus n, and log of AB is m plus n. Similarly, A divided by B is 10 m minus n, and log A divided by B equals m minus n. So what does this mean? So let's have a look at some multiplication if we want to do. So we have 5.67 multiplied by 3.8. 0.71. So we take the logarithms of these numbers, and here we get 0.7536, and here we get 0.5694. Those are the logs of 5.67 and 3.71. So when we want to multiply those, we get the logarithms and we simply add them, and we get 1.323. When we take the antilog of 3.23, we get 2.1. Okay. Now, we didn't use this 1. What does this 1 mean? The 1 here means we multiply this by this 1, means multiply by 10 to the 1. So our answer would be 21.